All right, guys, let's begin our tech talk today on what are mass properties in NX CAD. Now, your questions will be answered live at the end, but please go ahead and enter them into the chat as the questions come up if you would prefer. Our presenter today is Bilal, who's located in our Cincinnati office. He is an NX CAD application engineer. He leverages a strong foundation in manufacturing, innovative design, high performance motorsports, and advanced 3D printing. He's now channeling all of that expertise into driving innovation as a CAD application engineer. All right, welcome, Bilal. The Tech Talk is now yours.
Thank you very much, and welcome everyone, and thank you for joining today's Tech Talk on mass properties in NX CAD. My name is Mohammed Bilal Syed, and I'm an NX CAD applications engineer here with PROLIM. And today's session will focus on how Siemens NX handles mass properties, how we can use this functionality to create more accurate, lightweight, and simulation-ready designs. And I'll be guiding you through how NX calculates mass, how to assign materials and densities, how to manage your material libraries, and why this matters for real-world product development. So, just for the agenda to go over this, we'll be defining what mass properties are and why they matter in NX CAD. Then we'll move into how to assign densities in NX, both manually and automatically through materials. After that, we'll explore the built-in NX material library and how it simplifies design workflows. We'll learn how to create custom materials and save them for future reuse. Then we'll talk about how to manage those libraries effectively across users and teams, and I'll walk you through a real-world use case to highlight the value of these tools in production. And finally, we'll transition to a live demonstration where you can see these concepts applied in real time. And just for the sake of time, I think I'm going to be doing this right after each slide, is we'll do a quick demonstration just to keep this flowing well. Now, let's start with the basics. What are mass properties? Well, in NX CAD or just in CAD in general, mass properties refer to the physical characteristics of a model that are based on its volume and its density. So things like your mass, your center of gravity, your moments of inertia, and these are essential for simulation, motion analysis, structural testing, and even cost estimation. Now, NX uses solid geometry of your parts or assemblies along with the assigned density to calculate these properties, and the goal is to ensure that your digital model behaves as closely as possible to the real physical product. That's especially important for things like fuel efficiency in automotive design, payload limits in aerospace, and even mold design in manufacturing. Now, why does it matter? Well, it matters for your design for performance, so ensuring that your proper CG and weight distribution involves the product balance and stability. So for example, a drone, or let's say a car, or even robotics. You might want to do it for compliance reasons. So for example, many industries have strict mass limitations, whether that's in your aerospace, EVs, medical. It could be, a different industry, different applications. So you might have your own compliance standards for that. You've got manufacturing costs. So material usage impacts the cost. So small changes in density or volume can add up, or, depending on what material you use, you might have different manufacturing costs. Then, of course, your simulation accuracy, which is probably the biggest one, which is simulations often rely on accurate mass properties so that, NX, for example, can run those with while making sure that everything is up to, I guess, as close to real-world simulation or real-world scenarios. And then, of course, your system integration. So it helps in early detection of interference and mechanical imbalance in your assemblies. Now, let's talk about the most basic method on how to, sorry. I should have covered this in the previous slide. But so this is how NX handles mass properties. So in NX, mass properties are calculated based upon your part geometry, the physical volume of the model, your assigned density, either which is your user-defined or material-defined, and NX uses this to calculate your mass. So, your density is your mass over your volume. So in this case, to find out your mass, you do your volume of your specific part multiplied by the density of the material. And of course, if no material or density is assigned, NX will calculate the volume only, and the mass will be shown as 0. So assigning density manually if you don't assign a material, NX won't show the part's density. However, you can still enter a density value directly into the part properties, and this is useful in early stage conceptual modeling when you're not concerned with the full material specs yet, but you still want a mass estimate. And so NX will take that part's volume, multiply it by the density, and then give you that calculated mass. Now, how to view mass properties in NX, and we'll do a very quick run into a very quick and short demo. But so how to view it, you go into your analysis tool and you go into your measure bodies, or in fact, let's just run this live. Let's open up our NX. So here I've got my little body over here, and what I'm going to do is I'm going to go to my analysis tab and my measure command. Now, as I'm opening this up, one thing I'm going to do is I'm going to reset it to default. So this button resets a dialog box, any dialog box, or that particular dialog box, to its default properties. So right now, once I've clicked it, it's now exactly what you're going to see if you opened up NX for the first time. Now, this is the most important thing, which is setting your selection filter. If I were to just take this object and click anywhere, it's going to start selecting faces, it's going to start selecting edges, things that I don't necessarily want. But if I go to my selection filter over here, change it to solid body, and then come back, now I'm selecting solid body. So these are my cores from my casting, and this is, let's say, the body I want to subtract my pieces out of. Now here I just have a quick information window, and it's just asking me, because I hovered over there for too long, which body I want. So I'll just click on that one, and here we have it. We've got some of our mass properties here, and now I can choose what I want to do with it. Now, this is another important step, is confirming the settings that you want to keep. Now, by default, NX will keep fix at current timestamp always toggled on. If you want it to be associative, it's not necessarily going to change anything when you change the mass of this object or if you start cutting material out, because it's still fixed at that current timestamp. So if you want to keep it associative, make sure to uncheck this. Now, let's say if I wanted to create certain geometry, what if I wanted a little ball that denotes where my center of gravity is? Well, that's what this create geometry does. So if I click on that, you can't see it right now, but you will soon. It will then create a little, I call it a carrot, but it's essentially a ball of where your center of gravity is going to be. And now display annotation will display the entirety of this window up as a reference that you can use. However, if you want particular callouts, go here into this, into basically where your callouts are, and now you can choose which ones you want. So let's say I want my volume, I want my center mass, and I want my mass all to be shown to me. And I don't necessarily care at the moment for my moments of inertia and whatnot, so I'll just press OK. And now I have my mass properties here. It's associative, so if I start removing volume, or if I start removing the materials out of this engine block, it'll then update accordingly. However, if I had fixed at current timestamp, then it would not show me that. And so it's very important that you make sure to unclick your fix at current timestamp if you want to have your associativity turned on. Now we're going to go back, and I'm going to show you how to manually assign densities. So manually assigning densities, as I mentioned, is probably one of the most basic things you can do with like estimating your mass. So the command can be found in your menu, edit, feature, and solid density. Or you can also search density in your command search bar. And the way to use it is you select your solid body, you assign it a density, and then you click OK. Remember, it is just the density that it's changing. It's not adding any material properties. You might be adding the material property for, let's say, steel, or the density for steel, but NX isn't going to know that, okay, this is supposed to follow steel. It just says, okay, this is this dense, and that's all I know about it. And I'm certain once you start getting into simulation, NX will probably ask you for those values. However, it's best to just assign a material already before you start to go into your simulation. And you can always assign your materials at any point in your design process. So how can I change the density? As I mentioned, I can go to my menu, into my edit, all the way down to feature, and then solid density. Now here, I can select my object, and by default, I've got this density here. And what I'll do just for demonstration purposes is I'm going to move it just a decimal point over, and I'll click apply. And now we can see my mass has been reduced by about a factor of 100, or I guess factor 10. And I'll just bring it back up, and I'll select my object again. And once I click OK, you'll notice that, again, it changes it back to what it originally was. And so very easy, doesn't take a whole lot of work, simple. All right, now, how to use predefined materials? Well, NX includes a library of engineering materials. So NX comes with a built-in material library containing a wide range of common materials, such as steel, aluminum, plastics, composites, and so on. And each of these has its own or has predefined physical properties, including density, elasticity, thermal conductivity, and more. And by assigning a material to your solid body or component, NX automatically applies the relevant density, and this ensures mass calculations are always in sync with design changes. Now, you can also switch materials on the fly to compare different design scenarios. For example, aluminum versus titanium, and immediately see how the mass and center of gravity shift, and it's a powerful way to drive informed design decisions. Now, what I am going to do is I'm going to go back into my NX, and over here I have my center, we have my little piece, and one thing I forgot to show off is actually my little center of mass caret, if you guys can see it. So it's kept over there. You can see it right there. So I'm just going to go back into my isometric view, and one of the things I'm going to do is I'm going to start assigning this engine block a material. How can I do that? Well, in fact, I'm going to cover that in the next slide. Oh, sorry, it's in this slide. So you can assign materials under Tools, Utilities, and Assign Materials. So let's go to our Tools, Utilities, which is the base group, and then Assign Materials. And now I get to select my body. Here I have a material list. I can choose local materials or my library materials. I can also choose what library I want, whether I want to use a user library that I have, or if I want to use the default material library in this case. I'm just going to do a quick reset. And now it'll always be your library materials. That's the default that it opens up with. And I'm just going to select my body. Now I'm going to say this block profile. And let's say, I'm assuming this is in steel, but let's make it cast iron. And we'll apply that. And we can see, okay, there was a slight reduction in mass because we made it out of this particular alloy of cast iron. So it's pretty simple to assign materials. Now, you can also inspect those materials through this window here. So by right-clicking, I can do Inspect or Information. If I do Inspect, it'll then open up a different dialog box where I can just double-check and make sure that I have everything exactly how I want it. And of course, you've got more views that you can look at, but that will be covered further into the presentation. So now, of course, sometimes the built-in materials aren't enough. Maybe you're working with a proprietary material, or your supplier has provided a datasheet with exact specifications, and that's where the custom materials come in. So of course, in NX, you can create your own materials and enter all the necessary properties, whether that's your density, your modulus of elasticity, your yield strength, etc. And this ensures that your model matches the real-world behavior. And you can also group materials into custom libraries like company standards or lightweight materials, which makes them easy to organize and reuse across projects. Now let's just quickly go over our dialog box after the next slide. So creating custom materials, you can also clone and customize materials by right-clicking a material, and you can configure whether to use those values from the original material or overwrite those values. And as always, if you don't quite know how to use a command in NX, you can always click the question mark icon on the top right of the dialog box or hit the F1 key while the dialog box is open. Now, let's go over our materials dialog box. So here you have different ways to assign the material, whether it's select your bodies, you want bodies without an assigned material, all bodies in your work part, and of course show shortcuts is just, it puts them all in an icon format rather than a drop down. Now here, I'm going to select my body again, and let's take a look at, let's say if I wanted to make this out of aluminum 6061. And if I wanted to inspect it, like I showed you guys earlier, just to see what the densities and the other volumes are, I can do that. And if I really wanted to, I can change it too, but I wouldn't recommend changing anything in the default pathway. I would always recommend cloning, and then it'll automatically put you into this isotropic material format or just into this dialog box. It says isotropic material because that's what the type of material is categorized as. And let's talk about the views I was talking about. So here I've got design, and I can choose, what type of things I want to see, just so I don't get overwhelmed with the amount of things on this dialog box. So it shows me the mechanical properties, anything to do with strength, the formability properties, as well as any miscellaneous things that I want. And that probably comes from the visualization. However, if I wanted to see everything and absolutely everything, I can go to all properties. And this will then become a little bit more overwhelming or a lot more populous or populated. And once I can just get this to get bigger, I can now see everything. I can add descriptions. I can, check properties based on my property view. I can, assign different dependencies. I've got a whole bunch more properties I can then change, such as strength, durability, formability, which we had already, but thermal, which I think is very important, especially if you're doing any sort of CFD or thermal flow analysis. You've got some electromagnetic properties, you've got a creep, viscoelasticity, viscoplasticity, and other physical properties. There's so much more. And then of course, if you have an add-on, you might also be able to assign pedestrian protection or pedestrian protection properties to your materials. I believe this is available through our vehicle design add-on. Now, so that's how you can edit or take a look at your material. Let's think about how to create a custom material all from scratch. Well, I can just come down here to my new material and just click create. So then it puts me into a completely, it has no properties, and now you can go in and assign whatever you want. In this case, let's just say I want my formability and visualization turned on, and I'll say the name of this new material is I just made this, and we'll give it a description. Hello, guys. And now I can add a mass density to it. So we'll give it a very light density. So we'll just say 2.5. And then, of course, since this is kilograms per millimeter cubed, I'll say 2.5 thousand kilograms to, and oh, wait, this is per millimeter. So I'm going to change that up to 6. -6. There we go. That makes more sense. All right. So you can then apply, your Young's modulus, your Poisson's ratio. All this is material science, and of course, us that come from a mechanical engineering background or even just a materials background would know exactly everything that we want to change. If, let's say, this is, a completely custom material that you're making, and this is just an example of an isotropic material. If I wanted, I can make composites within NX as well. But for the sake of this demonstration, I'll just say I just made this, and I'll assign this to my block over here. So it automatically selects my body, but in this case, I want to make sure that I'm using the correct material, and I'll just double click on that. Oops, that opens it up. I'm going to assign this, so I'll just click on apply. And now that I've applied my new material called I just made this, you can see that the change in the mass, and it now takes up those properties. But let's say if I wanted to modify this cast iron, if I wanted to create a new alloy and, I don't have the alloy in my default library, well, I can right click and click on clone. And then this will open up a dialog box, which allows me to then edit and modify this alloy or change up the material properties to what is closer to what I want it to be. So let's say this is G40. So I'll just say G40 underscore secret blend, or I guess secret alloy. And then I can also add in a description if I want to, more things that you can play with. And of course, as always, if I don't know what to do, I can always click this help icon, and it'll probably open up off screen. But here's what it looks like, the material dialog box. And it'll tell me everything I need to know about the different about everything in the dialog box, like what is the name, what does the inherited value mean, what does overridden value mean, what does read only mean, and all of the above. And of course, since this is a very, 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 I want to say it's probably one of the largest dialog boxes I've seen. It's probably got a lot of information here for you to then take a look at and then possibly even understand. So Siemens has a lovely system of self-help, and I would highly recommend everyone gives it a shot, or at least start clicking on question marks. Yes, it'll open up a different tab, or it'll take you here and there, but it's a great way of learning how NX works without having to Google every little thing and then watching 5 videos before you actually get to the part that you need. So, highly recommended. But how to change these properties up to what I want it to do? Well, if I click on this, I can change it from inherited value, so no override. So it keeps it the same as the parent material that it came from. So in this case, the cast iron G40, and I can change it to overridden. And let's say this secret or this new cast iron alloy is actually a magnitude less dense than our previous one. And let's say it's a little bit more stronger. And I can change whatever I want. And once I press OK, and the nice thing is, here I can see everything that I've changed in this reset to defaults. And if I wanted to select them all or select particular ones, I can reset them. But this is a great way of seeing visually that, okay, these properties have not changed. And these are running off of what the previous or what the parent clone is. Sorry, not the parent clone, what the parent material is. And this tells me what I have changed in my clone. And it gives me a nice side to, or not side to side, but yeah, side to side comparison of what my inherited value was and what my current value is. And once I press OK, I can then assign this material again to our lovely cast iron block, hit apply, and there we go. I have changed my mass yet again. Now, let's talk about our mass and our center of gravity and how we can kind of edit and play with that a little bit. So one thing I'm going to do is, let's say, you know what, I'll just assign it tungsten because it'll be quite hilarious. So we've got our 1-ton engine block, great for visualization purposes of how to see your material actually move and how this is actually associative rather than me just telling you it's associative. So I have this engine block. I have a bunch of these cores for my casting that I want to, subtract from this material. So very simply, I'm just going to do a subtract command. I'm going to select my target, and then I can start selecting my bodies. In this case, I'm just going to start selecting them out over here just because it's just easier to do rather than me moving the model around and then just, clicking things. And now once I press OK, keep an eye on that mass and that center of mass. Once NX calculates it, you immediately get a change saying that, okay, your volume has gone down, your mass has gone down, and of course your center of mass is also moved. So let's take a look at where it's moved. And it is slightly off more to the left than it was earlier, if I remember correctly. And of course, this has gone down. Yeah, a very good representation of at least looking at a before and after and see how it associatively changes. And of course, as always, I have my center of mass right there, that little grayed black and white circle that I have. I forgot the actual name of that geometry. I think it's called a caret. But now, coming back to our presentation, let's talk about managing material libraries. So you saw me create a custom material. So once you start building custom materials, it's important to manage them well, and NX will allow you to save those libraries in shared folders so that all your team members that are working with the same material definitions can work together so that it improves your consistency and it avoids discrepancies, especially in regulated environments like aerospace or medical devices. You don't want two engineers modeling the same part using two slightly different densities. And of course, as a best practice, name your materials clearly, include version numbers if needed, and designate someone to review or update the library periodically. And to manage and export your materials into a file or folder, use the Material Library Manager command, where you can select all the materials you like to export and set the destination, and to always pull from a location by default, you can go into your customer defaults and set the locations from there. However, that will require a restart for you to actually start seeing that in your software. So how do I get to my, how do I manage my material library? Well, same place where I went to my assigned materials. Over here in the utilities, I need to go to more. Under more, we'll see there's a material tab that says manage materials and of course manage library materials. I'm going to click on that and go in there. Now here, I've got my default material library, and right now, I have my own material library selected because I was testing this earlier. Now, let's say I've got different materials that I want to either edit or inspect or export to a materials library, which is the most important thing that we're trying to do here. So here, let's say I've got my secret material. Where did it go? Well, let's just say I've already created a secret material, and here it is. So here, secret material X, crazy low density. It's almost infinitely. In fact, let's do a quick inspection of this material. This is a proprietary PROLIM material. Let's look at the description. It says PROLIM's top secret material that weighs nothing and is infinitely stiff, as you can tell. Great for all aerospace and medical applications. Now, let's say if I have the secret material, now in this case, I've already exported it and I have it in a library, but let's say if I wanted to share different materials or different material types, let's say if I have a multitude of random, or not random, but a multitude of custom materials that I have edited or changed or whatnot, how do I then start putting them somewhere? Well, you can either control and click different ones that you want to select, or you can shift click and it'll select everything between. So here I'll just say from secret material all the way up to my titanium alloy. If I wanted to export that, I click secret material X, shift click all the way up to titanium alloy. And now I can then choose what I want to do with this, whether I want to delete them, edit them, or export the materials to the library. In this case, I'm just going to export them. Then it asks me, where do you want it to go? This is important. You can, well, let me actually go back real quick because there's a drop down here. I can have a directory of MAT material library files or a single MAT ML file. In this case, I'll just choose single MAT ML file. And what I'm going to choose is I'm going to choose this Bilal's material library, and I can, in fact, select a file name, and it's going to put all the materials in this one XML file, right? Rather than export all the materials individually, that's where that's where the previous one comes in. But if I want it all under one MAT ML file, I can just do it this way, and we'll call this all my materials. And I'll press OK, and it'll immediately create a directory, or it'll then point to that directory, and you will then be able to pull from there. In fact, let's just do a quick check, just so that I can prove to you that I'm not just doing things here and there. Let's just go to I might have to come out of full screen mode here. Give me a second so that I can then pull up yep, here we go. So here, I've got my material library, and here all my materials is now kept as an XML file. Now, if I go back to NX, and let's say I wanted to export those as individual materials, go back here, select whatever I want, right click, and then export materials to library. And I can also do directory of MAT ML files, and I can still choose the same file. So I'll just choose this one, Bilal's library, and I'll press OK. And then once I press OK, it'll then export all those materials, and it'll say material successfully written to the specified MAT ML library. And here we go. I wish I had this on screen at the time, but it was just slightly off screen. So here it is, all my materials, all the other ones, and every single thing that I had put in or selected. And so now I can put this either in a shared drive and then have my engineers or designers point to this file either through the customer defaults or however we particularly manage this or manage our materials. Now, you might have the burning question of how do I do this if I have Teamcenter integrated? Well, I came prepared this time. I asked one of our engineers or application engineers that works with Teamcenter, and he suggested, or he told me, that there is a module called IMM, or Integrated Materials Manager. And that is what you would need to use to then allow, Teamcenter to then begin managing your material library rather than having a shared folder or a shared drive. Now, let's talk about setting that directory as your default. Well, if you go to your File, Utilities, and then of course Customer Defaults, and here is a quick tip for you guys, is if you need to find things in your customer defaults, you've got it's very subtle, but it's very powerful. One are these binoculars, which will of course help you find the default. And let's say you want to see what you have changed over time and you don't know what you've changed. This cog or this gear icon, Manage Current Settings, will show you everything that's changed from default. So these are all the changes that I've made over the course that I've been here with this particular version, and it pulls that in. But in this case, I want to find something, so I'll just say materials or material. And I'll press enter, and now I can see everywhere that there is a mention of materials. I can now see where that is. Some newer individuals to NX may not know this, which is why I'm showing this to you guys. Now here we've got, let's see, materials and mass. I'll go here. Once I click OK, it'll take me to that point. And so here in our gateway, we've got materials and mass, and now I can set my site ML library, whether I want a single matml file or a directory of matml files. And of course, by default, NX has its own, and you can also always see where those material files are by, again, going into your managed library materials. And here you can see where the library is. So here, the physical material library.xml, that's your default if you're running native NX. It might be different if you have Teamcenter integrated. And of course, my secret material X is in a completely different directory because it's not necessarily part of this physical material library. And you might notice that, hey, all of these are exactly the same. Why is that? Well, similar to how I exported all of my materials into a single XML file, you can do the exact same. All of these materials are in a single XML file stored in probably on one of your app datas for Siemens, and by hovering over them, which is a nice little thing you can do, you can also see the tabular data that they have. So in this case, yep, there you go. So I have tabular data for this particular one, which is, I think, our sulfur dioxide liquid, because you never know when you need some of that. Am I right, guys? But that should conclude all that I wanted to show you, at least for the basics of being able to manage your material libraries.